So for our notes today, we are working on our fourth kind of function that you guys need to know, which is our exponential function. So our exponential function has the form f of x equals a times b to the x power. And that's how you know it's exponential, is because if you look at where the x is, it's in the exponent spot. So that's why we call it an exponential function. It's exponential because the variable's in the exponent. Parent function, our most basic form of our exponential, would be f of x equals 2 to the x. That is our most basic form of our exponential functions. So the graphs of these functions are not straight lines, even though part of it does actually look like it is. In a straight line, your rate of change is constant. Remember, your rate of change is your slope. That means it's always the same in your line. But in our exponential functions, your rate of change either increases or it decreases across the graph. And we'll talk about that as we actually go through some of our graphs on here. So let's first practice a little bit of evaluating again. So evaluating means you're just plugging a number in. So they give us our function here, f of x equals 4 to the x plus 2. What do they want us to plug in for x? 3. So we're going to write f of 3. Every x that you see gets replaced with a 3. Equals 4 to the third plus 2. Do you guys remember how to get your little exponent thing on your calculator? Which button is it? The little caret thing. So we would be doing 4. This button here gets you in your exponent spot. And then your 3, you just have to remember to arrow out of it for your plus 2. So we got our 4 to the third plus 2. What do we get?
64.
I got 66. You didn't do your plus 2 yet.
Yeah, I thought you were just looking for the board.
Oh, yeah, no. So when we plug in a 3, we get 66 as our answer. For our second one there, what are we plugging in? A 2. So f of 2 equals negative 2 to the 2 minus 3 power. I don't know why I put an x there just now. So for our exponent, what is 2 minus 3? Negative 1. So really, I have negative 2 to the negative 1 power. So let's have you go ahead and use your calculator. So negative 2, my little caret key for my exponent, negative 1. Then we hit enter. We get negative 0.5. What is that as a fraction? Yeah. So f of 2 equals negative 1/2. They always want the fractions over the decimals. Do you guys remember how to turn from a... Oh, I missed the minus 4.
Yeah, that's what I said. 4.5.
Thanks for telling me. Completely missed the minus 4. My goodness. So negative 1/2 minus 4 gives us negative 4 1/2. Or we could write as negative 4.5. As I was saying, they do prefer the decimal, or the fraction over the decimal. And then our next part here, this is again just reviewing stuff we've already been doing. You're being given the graph, so all of your answers are on the graph. You just have to pull your answer from the graph. So they want us to find the value of x when h of x, which I'm going to replace with a y, equals 1. So we're looking for where y equals 1. Yep. So if I draw my little line at y equals 1, there's only one spot. That's when x equals a 0. So this time find h of x when x is a 1. So this time they're telling us x is 1. So I'm going to go to where x is 1. Look for my graph. My graph is at 2. And then 3 times h of 2 minus h of 0. Well, we just figured out h of 2, didn't we? No, we didn't. We got to go to where x is 2. Where's our graph?
4.
4. So we got to do 3 times 4. Minus. Go to where x is 0. Where's our graph? 1. So 3 times 4 gives us 12, and then minus 1 gives us our 11. Yep. So then these questions down here, we're going to use the graph in our calculator and our table of values to help us answer it. So we have the graph of the equation, y equals 3 to the x, contains which point? So let's go to our calculator. Go to our y equals. If you have anything in there, clear it out. So then we're going to do 3, the little caret button, so I can get my exponent and the x. So 3 to the x power. And then let's look at our table. So the first point is the point 1,9. So if I go down to 1, do I have the point 1,9? No, it's 1,3. All right, how about negative 2 and 1/9? Well, 0.11111, I don't really know what that is, so I'm going to go to my blank screen, type in 0.11111, math, enter, enter. It didn't help me any. So how else could I figure out if that's 1/9? How about if I just do 1 divided by 9? Is that the same decimal? Yeah. The table can't show you all the numbers. It has to end it at some point, but that's going to be the same number, so that's our point right there. Negative 2 and 1/9. So I want you to try this next one on your own. Doing the same thing. Here's your equation. Y equals 5 to the x power. I want you to find which point is on the graph. Yeah, this one's choice 2, the point 0,1. So those ones are pretty easy. Take a look at the back. So a lot of times they're going to ask you to graph your exponential function. So some things you need to know when you go to graph it is, as always, you need a table of values, and you want to have at least 5 points on your table of values. Within those points, some of them have to be decimals. So some have to be decimal values. The rest of them will be whole numbers. So you got to look for that. And again, sometimes your domain is given to you, like this, for example. Negative 2 is less than or equal to x, less than or equal to 4. They're telling you what x values to use. They're telling you to go negative 2 up to positive 4. So it's nice when you give you what numbers to use already. You're going to plot your points and connect them with a smooth curve. If your domain is not given, you put arrows. If it is given, you don't put arrows. And then we've got a new line we're going to talk about in a second. But let's take a look at our first one. So we have f of x equals 2 to the x. Remember, that's our parent function. That's our most basic form of our exponentials. They tell us for the domain negative 2 to 4. So they're telling us what x values to use in our table. We're going to go negative 2, negative 1, 0, 1, 2, 3, 4. So what I want you guys to do right now is fill in the rest of that table. So go to your y equals, type in your 2 to the x, so you can practice typing that in. Let's have you get the rest of the table. Remember, you're going to have a couple of decimals in there. So where is our y-intercept? Not 0. 1. We cross that y-axis at 1. Is this graph increasing or decreasing? Increasing. So remember, if we start from the left and I follow my graph going up, this one is going to be an increasing graph. That's one of the cool things about exponential, is it's either always increasing or it's always decreasing. You don't have both at the same time on these graphs. For this one, they want us to state the range. Now, when they give you, this is your domain, your range is going to look very similar. It's going to have the same setup. We just have to fill in our numbers. So what is our smallest number? Our 0.25, so that's going to go over there on the left. Not 4, the 16. Yeah, we got to use that y number. So 0.25 less than or equal to y less than or equal to 16. So in here they want us to find the average rate of change for the interval -1 to 1. We've talked about this before. Remember, when they write this, those are your x values of 2 points that they want you to use. So we're looking at where x is -1 and where x is +1. So if we look at our table to finish off our point, it's -1.5 and then +1 what? 2. So you have to get your 2 points first, and then we use our slope formula. y2 minus y1 over x2 minus x1. So 2 minus 0.5 over 1 minus -1. So 2 minus 0.5 would give us 1.5. Down below there, we're going to end up adding, so 1 plus 1 gives us 2. So then divide those. What's 1.5 divided by 2? 0.75. So there's our average rate of change from -1 to +1. Yep, or you could write it as 3/4. You can also leave it as 0.75. So then they want to know what happens to the average rate of change for the interval -2 to 2 when compared to the interval of -1 to 1. So we already found this one. It's right up here. We have to find what is our average rate of change when they make our interval bigger. Instead of just -1 to 1, we're now going -2 to 2. So let's write our 2 points. We're going from when x is -2 to when x is +2. So -2 is 0.25. +2 would be 4. So 4 minus 0.25 over 2 minus -2. y2 minus y1 over x2 minus x1. So let's subtract. 4 minus 0.25 gives us what? 3.75. Very good. What would our bottom be? 4, because you minus a negative means you're adding it. So now we got to figure out what is 3.75 divided by 4. You got it, Athena?
0.9375.
Athena?
0.9375.
9375.
You want us to round that?
No, we'll leave it as that. So what happened? It went from 0.75 to 0.9375. So our average rate of change did what? It increased. So they asked, what happens? It increases. So whenever you take your interval for your average rate of change and you make it bigger for your exponential, your average rate of change should also get bigger. That's why this one's an increasing graph. If I had a decreasing graph, what do you think would happen to it? It would have gone down. So it does exactly what the graph does. Now, if we had our linear one, that wouldn't change. It would have been the same average rate of change no matter what part of the graph we looked at. All right, so let's take a look at the back. Last page of our notes. So this time I already graphed it for you. Your y equals 2 to the negative x minus 2. So let's answer our questions over here. Is this graph increasing or decreasing? This one's decreasing. How can you tell from the equations? It's easy to tell from the graph that it's decreasing. Where's the negative though? Perfect. How can you tell? The negative in the exponent. That's what made it decreasing. Nice job with that. So next they want us to state our domain and our range. Now domain, again, we have arrows on both ends of these graphs. It's going to keep going on forever. So our domain is still x is an element of the reals, meaning it can be every single real number. Our range, however, is not going to be like that. If we take a look at the range, you see how it kind of looks like it flattens out down here on this part of the graph? So what's happening is it looks like the graph is getting to -2, but it's actually not getting to -2. What happens there at -2 is this is a special line that we refer to as the asymptote. Right here. What that means is it's a line that your graph is going to get closer and closer and closer and closer to, but will never actually touch or go over that point. So our asymptote in this equation would be y equals -2. So our range is y is greater than -2 because our graph is entirely above the asymptote there. So it's really easy to also be able to tell where your asymptote is going to be because it's whatever that last number is. That's our asymptote there. So let's say, for example, I give you the equation y equals 3 to the x minus 5. Where would my asymptote be there? At the -5. Our asymptote would be y equals -5. How about if it was y equals 4x plus 7? Our asymptote would be at y equals 7. Whatever that last number is, that's where your asymptote is going to be every single time. So if we went back to the other one that we graphed, y equals 2 to the x, where would our asymptote be for that? 0. There's no number at the back here, so our asymptote would be at the line y equals 0, because it's like a +0 that they didn't write. Okay, let's take a look at our last part here. Average rate of change from -4 to 0. So again, those are our x values. We're going to look at where x is -4 and where x is 0. Yeah, we got to look at our graph here. So here's where x is -4. Oh, it's not 13. It's 14. Yeah, and then the 0 is easier to see. 0, -1. If you can't really tell from the graph, since they gave us the equation, you could put it in your calculator and then look at your table of values that way. So y2 minus y1 over x2 minus x1. -15 over 4, which gives us what? -3.75. Which makes sense that that average rate of change is negative because our graph is a decreasing. So all of your average rate of change would be negative for those.